Very good evening to one and all. Myself, Ritvik Reddy Jetta, and I'm here to give a research presentation on lightweight recoverable virtual memory. My teammate Pramod Vasireddy is currently unavailable, so I'm doing this video presentation all alone. So, coming to the introduction part, before I get into the details, let me first tell you what recoverable virtual memory actually means. Recoverable virtual memory refers to those regions in a virtual address space where transactional guarantees are offered. A transactional guarantee basically refers to a program that ensures all non-interest and certain low-interest bank accounts do not generate interest for a specified amount for a specified period of time. And the basic transactional guarantees include atomicity, serializability, and permanence. And atomicity requires each transaction to be all or nothing. That is, if one part of the transaction fails, then the entire transaction should fail, and the database state should be left unchanged. An atomic system must generate atomicity in each and every situation, including power failures and errors and trashes. Mm. Serializability ensures that no two transactional uh, operations overlap. By doing so, it is ensured that the operations are executed in a sequential manner, that is, in a sequence. Permanence is a state of being permanent or unchanged indefinitely, which means that the data on the database is left unchanged unless someone intrudes and does it manually. And the tra- uh, and the transactional facility RVM is an efficient, easily used implementation, and it is portable too. Its unique characteristic is that it allows independent control over the transactional guarantees. Uh, I already spoke about transactional guarantees like atomicity, serializability, and permanence. This transactional facility, the RVM, is run without the support of operating system, and all the previously implemented transactional facilities ran only with the help of operating systems. And RVM is the first of its transactional facility which did not require an operating system support to run in an efficient manner. And RVM basically was intended for using Unix applications with persistent data structures, which have to be updated in a manner that it is having no faults. Now, there were a lot of transactional facilities that were implemented prior to the RVM, out of which CAMELOT is one such facility. CAMELOT transactional facility has got a major influence on the design of RVM. RVM was basically designed in a way such that it overcame the limitations caused by CAMELOT. So before I go further, let me first tell you the influence CAMELOT has had on the design of recoverable virtual memory. CAMELOT is basically a transactional facility built to validate the tests that general purpose transactional support would simplify and encourage the construction of reliable distributed systems. Uh, It relies heavily on external page management and inter-process communication facilities of an operating system named Mac. Uh, this figure in this slide gives a basic structure of a CAMELOT. It gives you the complete internal structure of the CAMELOT transactional facility. There are a lot of modules in it, as you can see. Each module is basically a task on the Mac operating system. The operating system ensures that there is inter-process communication among the modules present here. With the help of its inter-process communication facility, uh, coming to this slide, the Mac operating system that is present in the structure of in the previous slide consists of different tasks like master control, CAMELOT, and node server, as well as recovery, transaction, and disk managers. CAMELOT provides RVM of data servers, that is operations. Transactional operations are the virtual address space of each data server. Application code can be split between data server and application tasks or may be entirely linked into a data server's address space. The CAMELOT facilities are accessed via a library linked with the application code. Implementation of CAMELOT. Like there's good and bad in everything. In spite of having a lot of benefits and positives, CAMELOT has got its own share of limitations too. And it is these limitations that made it necessary for a transactional facility like RVM was designed. The major limitations encountered by CAMELOT are poor scalability, programming constraints, and difficulty of maintenance. Lot of experiments showed that the primary contributor to the loss of scalability was the increased CPU server utilization. Because of this increased CPU server utilization, the whole CAMELOT transactional facility became regarded as a poorly scalable one. The second obstacle to the usage of CAMELOT were the programming constraints that it imposed. These constraints came in a variety of guises, and each of these guises actually convoluted the whole procedure and made the system administrative scripts very complicated. The third obstacle was that CAMELOT was very difficult to maintain. It was difficult to maintain because of its code size and also its complexity, and also because of the type dependence on some rarely used combinations of operating system Mac, which made the maintenance and porting difficult. And coming to the design rationale of RVM, uh, the central principle adopted in designing RVM was to value simplicity over generality. Uh, Here is the figure on the layering of functionality within the RVM. This is actually a layered implementation, and normally layered implementation may be less efficient than a monolithic one, but it has this attractive property of keeping each layer simple. The upper layer can count on the keen failure semantics of RVM, while the latter ones are only responsible for non-restricted transactions. Coming to the next slide. It is again about functionality. The RVM normally adopts a simple approach which ensures that flexibility was enhanced. And second area where RVM was simplified was in the area of concurrency. Rather than having an insist on a specific technique, it is designed in such a way that the concurrency control was uh, sorted out. It actually allows to uh, applications to use a policy of update on choice, such that the synchronization was applied in such a way that it was appropriate to the abstraction that may be in supported. Third and final simplification is to basically implement the multi-threaded function to correctly function in the process of two parallelism, and it is also ensured that the factor of resiliency to media failure is reduced by employing some standard techniques like mirroring up, which is used to achieve resiliency. And expectation is that this functionality is most likely to be implemented in mirror disk inside a device driver. Coming to the structure of RVM, uh, I'll now give you an overview about the structure of RVM. And CAMELOT, as we already discussed, was designed in such a way that it had a it had an interprocess it has an interprocess communication without compromising on its good performance. And the desire to make RVM portable and to and willing it to make uh, run in a good way actually depend on a good way. RVM was basically designed in such a way that it ensured both interprocess communication was ensured along with giving a good performance. So RVM as a library